Yes. So, hello again, everyone. I'm going to go through commits and investigating the commit tree, navigating through it, and seeing all the history of the commits that we have been doing these days. Sorry. Let's see what is a good size for this. Is the font for my terminal window big enough?
You're not sharing your screen. So.
Oh. Sorry for that. So is the font for my window big enough?
It is fine for me, but I have a large screen. People with laptops, can you see it?
Yeah, I think
Okay, great. Otherwise, just tell me. So it's all about commits in the next 25 minutes, and we'll continue with this tomorrow. But what we are going to do is to investigate the history. And when I say history, I mean the history of our commits. So all the snapshots that we have been taking of our working directory or our tree. And the way we can do that very easily is using the git log command. So you should have a repository which looks similar to this, at least if you followed strictly what Birite was doing. If you have done it differently, that's perfectly fine. But typing git log is going to give me the history of all the commits that I have on the branch that I am on. So maybe let's stick to this one here. So git log, by default, it's going to show the latest commit on the head that the head points to, and then all the parent commits of that commit. The head is now pointing to this commit 84, and it also has a reference. You can see here head is shows this pointer arrow to a reference, and that is the master reference. So a reference to the branch called master. And so we see, so as I said, the hash of the commit, we see the author, so who has done this commit, author and email, the date that the commit has been done at, and then the commit message. In this case, it's only one line, but if you have a longer commit message, then it will be shown in its entire, the entire message will be shown. And then what we have in the following is the parent commits. So as Birite was demonstrating in the last lecture, so we have the latest commit points to always points to the snapshot of the working tree, but then it also points to the parent commit. Or it can be several commits, several parent commits if we have a merge commit, but at least one parent. So we have the commit, one parent commit in this case, and then again the author and the date of the commit and the commit message, and the list can go on and on. And if we have okay, sorry, I'll go back to that later. So by default, if I only specify git log, then this reference is going to be taken as the head. So the hash that the head points to. But if I only want to see the history from a given commit, then I can just specify the hash of that particular commit. So this is the reference. Reference is some commit with the hash D9 2 and so on. And of course, I mean, I could have a long hash. This is the long hash, but as Birite said, I mean, you can use a shortened hash. And sometimes it's enough with just a couple of numbers and letters. It just depends on how many objects you have. If it can sometimes you can solve it just through 3-4. But anyway, usually you just pick a few, and you can use that as a reference for your commit. So git log some hash, and again it will show that particular commit followed by all the parents, all the ancestors of that particular commit. Now, if you only want to see the latest, I don't know, 10 commits, for example, if let's say you have a commit that you have a repository that you've been working on for a long time and you have hundreds of commits, showing the entire history maybe is not what you really want. You just want to see the latest 10, for example, then you can use this option -n, which is the short for number. And then a number of how many commits you want to show. So it will take the hash of the reference and then all the ancestors, a given number of ancestors to that particular reference. Another option with git log, which I find very useful, is the one-line one. So let me go back 2 slides or just 1 slide. So by default, it will git log is going to show the entire hash of the commit followed by the author and date and the entire commit message. But with 1 line, it's going to just show a shortened version of the hash of the commit, followed by the first line of the commit message. So in those cases, this is the most recent commit, and all the references that we have associated with those commits. So in this particular case, the head, so the latest commit has head reference to it, and this is the default. Usually head points to the very latest commit, unless we change that, and we will see how. In addition, head also points to the tip of the master branch. So if I have several references, they will all be given next to these commit hashes when I investigate the history with git log 1 line. And some, let me just go back to this example here. So let's do a clear here and show git graph again. So I just wanted to show you that here, for example, I had that other second branch. So I have the reference second branch, and git log shows that. So for those of you that do not have this alias defined, so what git graph actually means is git log 1 line followed by graph all to show all the branches and decorate. So instead of typing git graph, instead of typing this long command, I just defined an alias, which is called graph. So the output is exactly the same. Okay. One can tweak the format, the output that git log shows by adding many different options. And I will only show you the ones which I think are interesting. But if you really want to know about everything, then I think Git SCM, so where from you actually downloaded Git, is a great resource. So I can go, for example, just in the search bar there and type git log, for example, and then I can actually see everything that I can do with git log. And for and you can do this for all the commands, and it is somehow more readable than doing git log help, for example. And usually there are also some nice examples that you can see. Okay, git log has really many different options. But I just want to tell you that whatever command you are interested in, you can find a full documentation on the Git SCM page. Okay, let's go back to the lecture material. So there are many different options. One useful one is to use git log together with the option grep. So --grep equals some regular expression. So let's say, for example, that I want to search in all the commit messages, I want to search for something that contains the word bug. Then I'm going to type git log --grep equals the word that I am trying to find. So in this case, bug, and this in this particular case outputs one particular commit. It shows again the commit hash, the author and the date, and then the commit message, and you see that bug is actually found in here in the commit message. But I mean, of course, this is just an example. In some cases, you may want to look for some other word. One point I want to mention is that this is why it may be actually important to have good commit messages, because if you want to find something in the commit history, then it may be easier if you actually have good commit messages and will help you find something in particular later on. But of course, I mean, this comes with practice as well. So sometimes it is not trivial what a good commit message is, but try to do your best, try to be explicit about the changes you have introduced and why you have introduced them. There are also other options, for example, --after or --before, and used together with a certain date can show you the commits which have been performed after a given date or before a given date. Let's say that you've been away on vacation for a while, and then for 2 weeks, for example, and you want to know what happened in the last 2 weeks. Then you can use git log with the option after, for example, and say that, okay, what has happened in the previous 2 weeks. And this is helpful, yes, especially, I mean, if you are working on a repository together with other collaborators. Okay, more options. Stat, for example, is going to also list which files have been modified in different commits, and also which lines in those files. -p can be very verbose. I mean, it's going to give you a lot of information because it will show the differences between the different commits, and that can be a lot, but it is useful. We have already used this option before, the graph option, and maybe actually highlighting is not good for you because it makes it so light. Sorry for that. But the option graph visualizes the commit tree. And if you want to see all the branches, by default, it's only the branch that you are on. So the branch that head points to. But if you want to see all the branches, you do need to have this option --all. So in this case here, we use log together with graph all in one line, and then one line will show again one commit per line, and then all is going to show all these different branches. In this case, we have a branch which is called master, and then we have an additional one which is called second branch. So let's move on. In addition to the log, so we can also use the so-called ref log. So let's step back one step. So git log is going to display only the changes that affect the commit tree. But if for some reason you discard some changes, or well, you discard some commits, and we'll see that in a bit, then you lose the information on the commits. But one way to retrieve that is by using the reference log, ref log. So ref log is going to it's a way of tracking it of all the changes that happened to head. So whenever you change the hash of head, then there is going to be a reference in this ref log. So for example, if the tip of the branch or other references are modified, then again it's going to be shown in the reference log. And the way you can do that is using this git ref log command. And let me show it in the terminal, and you can also try that if you want, just so that it is a bit clearer. So you have a list here of all the commits that, of all the commands that have changed the head. So for example, from the oldest to the newest, so oldest is already always at the bottom, we have done an initial commit. So we use the git commit command, and we changed the head reference to this particular hash. We did an additional commit that changed the hash again. We did a checkout, possibly, which again changed the hash back to the first commit. And then for most of you, the latest one, the git merge command, which has again changed the hash to this commit. So this is useful again if you remove some commits from the git log history, but you still want a convenient way of retrieving it. And we will have an exercise with this so that it can help you understand why this is useful. Okay. So we can, for example, create and discard a commit. I can do this in the terminal here. So let's do a git log again to see. So I have, I'm going to do a checkout first to the very first commit. So I will just copy paste some of those. I am in a detached head state. What does that mean? It means that my head is not pointing to the tip of a branch anymore. It doesn't have a reference to a branch, in other words. I can also see that by checking in this hidden Git directory, git refs, and then the file head. No, heads first and then head. I was expecting a head file there. Oh, it was just under. Sorry for that. So yes, so the head reference actually does not have a branch reference anymore. So I am in this detached head mode, and I can, let's say I can change this file, txt. Yes, Lucas? Lucas?
Hi. For
Yeah.
this graph that you have, the stars and the lines, can you explain a little bit this graph? Like the star in the bottom, what does it mean? What does it mean, like the star on the top? Why there are different
Yes.
color
Yeah.
lines?
So the stars, so there is a star for each commit. So you have one star here for the very first commit that we have done. And then we have done additional commits, the second one. and then we moved back to the first commit and added this additional commit. Sorry, I said it the other way around. So, but anyway, we had different commits on different branches, and then we attempted a merge in the last lecture, where we have merged the contents of the master branch and the second branch. So the stars are simply, well, one star for each commit, and then in order to show the parents of each commit, so there is going to be lines from the star to the other stars. So this particular commit, F1, is a child commit of these two commits where the tip of the branches were. So F17 has two parents, the commit A0 and the commit 5B. And then this commit 05 has two children, meaning that from this commit we have two branch reference. I mean, we initially had the master branch, but then from here we also created a different branch. So the line of work split into two, the master one, and then this second branch. So that's why I have these green lines which are pointing to different commits following different branches.
It only shows the commits, not the stages, right? Before you commit, you have that stage that you didn't commit. These only
It
show
only
the
shows the commit. Exactly.
Okay.
Yes, it is true. So the staging area is a snapshot just before the most recent commit. And you don't have, and the staging areas before different commits are not kept. You only keep the one for the very latest commit. So you say, okay, in the next commit, I want to include these modifications. So then I stage them with git add. But once you have done the commit, then it's not important anymore. I mean, the staging area is cleared because you have saved your commit. So indeed, I mean, so all these different commits are snapshots to the working directory. So in my case is this directory called course repo. So our snapshots of this directory course repo in different points in time. So I have the hash of the commit, and then in this case, it was pointing to some version of the file txt. Later in time, I have modified that file, so I have different snapshots of this particular file. Or if I have several files in my directory, I have snapshots of my entire working directory, or tree, as it's sometimes called.
Thanks.
Is this clear now?
Yeah.
Okay.
Just one last question. For
Yeah.
each commit in here, we are using an example, just one file, but can it be the case that one commit has several files associated with it?
Yeah, sure. You can have as many files committed as you want, or
No.
as many modifications you want. Or
A same slash being associated with several files.
say
Like for
again,
So in the example that we have in here, I think each commit is related with just like one file, the
Yes.
txt that you created.
Yes.
Could it be possible that the same commit is associated with like a 3-4 files?
Yes, it is possible.
Okay.
So you can have several modified files in one commit.
Okay, thank you.
Definitely. And that is usually the case, but it's easier to keep track of one file than several. So that's why we chose one for the examples. But definitely you can modify several files in one commit, and that is the norm. And the reason for that is because you don't you usually want enough commits so that it's clear what you've done, but you don't want too many commits so that you clutter the Git log. So you have to find a happy compromise when you are taking snapshots of your working directory. So when you are committing your changes. As a beginner, it's usually better to commit more often. It's also easier to debug if you have made if you have introduced some errors in your files. But then sometimes if you have like, I don't know, if you have 20 different commits in one day, then you'll find, oh, this is very annoying. I should just try to have fewer commits so that the history is more readable. But again, I mean, it's a matter of preference. So let me just see where we are. Okay, let me just do 2 more slides, if I may, and then we are going to call it a day and continue tomorrow. So let's assume that I want to create and modify this file txt. So I was in this detached head state. So I moved back in time to this first commit, but I don't have a reference to it. But I am going to modify this file by adding this line, more content to this file. And you can use this command if you want to edit it, but I will say more content to this file. And I'm going to save it. Use your preferred editor and use the command git commit with the option -a to stage all the modifications that I have. Actually, before I do that, I'm going to show you git status. So what git status tells me, it warns me that I am in this detached head state. It also tells me I have one modification to the file txt. It shows it by default in red, or at least on my terminal. And what I can do is I can commit these changes using git add, or I can discard them. We'll see how we can discard later. But git status is very useful because let's say you don't remember some of the commands, it can actually hint, oh, is this what you're trying to do? Do you want to commit your your changes? So I can do git add to stage this modification. So this tells Git, okay, include this modification in the snapshot. So next time I commit, this change will be included. And then I do that using git commit -m and some commit message. I am going to delete this. So if I use git commit -a and -m together, that just means that I stage all modifications in this working directory and commit. So instead of writing 2 commands, I can just type 1. So depends how much you want to write, really. It's of course nice to add the -a option, but then but then you may miss some modifications that you've done and maybe you do not want to include. So git status is always very good to do before doing any commits. Okay, so what happens now? Okay, let's do git log 1 as in the lecture. So I want to see the history. So head was pointing in this different commit, but now I have done a new commit on top of that one, where I modify the file txt. So I have a parent commit. Sorry, I have a child commit to 05. So let's say that, oh, actually, I didn't want to do this modification. I want to discard this commit altogether. And the command to do that is git reset. And reset is a great command of really cleaning your indexes, the staging area, and your working directory, because it is so good at it, you can actually lose some changes that you do want to keep. But in this case, I just want to remove this commit altogether, so I use git reset with head. But you see that I have actually a special reference to this hash. Instead of saying that I want to go back in time and reset the changes in my working directory to this particular version of the working directory, instead of typing that particular hash, what I can do is to say I just want to go back to the parent of head. So head tilde means that go back to the parent of head, and discard the commit head. And now head is pointing to this particular one. So if I do git log again, I see that the head is pointing to this first commit. What if I want to go back to this commit that I have done? Maybe I think that, okay, that change is actually still a good one. What I can do is git reflog, and I can still see that commit, which was named 38. I can still see that commit in the reflog, so I can refer to it that way. So I could, in principle, git checkout to that commit again. So let's do that. And again, I am back to that particular commit. And if I check the file, why am I missing this? Because I specified the wrong hash. So I copied the wrong hash. I should have done that one. Sorry for that. So yeah, head is now at 38. And if I check the content, I can see that I have recovered actually the modification I have done. So this is why git reflog is useful. But with this, sorry, I was going over time. So we are going to continue tomorrow with navigating the commit tree, and we are going to be doing exercises as well and discuss branches. So final questions before we go for lunch?